inflation and stuff like that. We ran some examples on that. There is an assignment, I probably should go back there before I went out. There is an assignment that is not due May 18th or whatever I said last time. It is due May 2nd. So this assignment is an individual assignment, it's just like an economics homework assignment. It is due May 2nd, which is next Friday? Next Friday? Is it possible Friday is next Friday?
No, just make sure it's rolling.
Yeah, it's due next Friday. Turn it in on campus.
No, I don't want to watch
Turn it in on campus, please.
Okay, good. Okay, well, I think I should.
And then so all these readings are online, as well as the handouts and the tables. So I'm just gonna go through this, just like I did before. I can answer any questions that you have. Oh shit. Okay. And today we're just talking about comparison of different methods. So the reason economics is so important for engineers to understand, the more economics classes you can take, the better prepared you will be to understand the issues that relate to your company. You're going to make a lot of these decisions or be part of this decision-making process. So certainly this is good information to know where you're just getting a little bit of information, but if you can take a class in this, I'd certainly encourage you to do something like that. Certainly will, again, help you to be an engineer. So today we're talking about different comparisons of alternatives, because as an engineer, lots of times we are going to make a decision as to whether to buy product A or product B, or in many cases it's, do I continue with this idea that we have, or is it just not economically feasible? And that's kind of pretty close to the point that all of your projects would be at if you worked for a company, is we would start to understand, okay, now that you've got a bill of materials, now that you've done the design work, I get a good idea of how much it's actually going to cost us to produce this product. Can I sell it for that? Is there a market out there to do that? And do we continue on with this or not? So I just was set up a talk. It's the very last day of class. We have our last quiz. And we have some people from Garmin that are going to come in and they're going to talk about their product design phases, the steps they go through. And they cancel like half of their projects. So they get them pretty far along and then determine that it's just not a viable product for that company, and so they all go and then do different things and evaluate other stuff. So, and again, that's pretty close to the stage that you would be at if you were really working for a company. So, and this is some of the things that they would do to compare these alternatives. So, these are all relatively straightforward. There's one of them, yeah, one of them is less straightforward, but I think these first few you're going to find are pretty straightforward. The first one is the present worth analysis. And in the present worth analysis, you simply determine what is the present worth of all the different alternatives. The superior option will have the highest present worth. It's pretty straightforward. This only works, however, when the life of the product is the same. So like if I look at this example here, I have machine X and a machine Y. I can't use the present worth analysis because the life of these machines is different. So I can't do that. This question here is, what is the present worth of machine X? So I would want to know, what is P, present worth? The cost of machine X is $6,000. So that is going to be a negative $6,000. That is already present day money. And then it's $150 maintenance cost, so it's minus $150. And now I need to know the present value of that annual at an 8% rate of return, not a percent, 8% rate of return for 7 years. You crunch the numbers, and that is a present worth of minus $6,781. So that is A here. In other words, that is the current present value cost of that product. So if I do have machines that have different lifetimes, generally what you're going to do is you are going to spread out the cost and the benefit over the life of the product, and you come up with an annual cost analysis. This is similar to what we talked about last time, which is a UEAC, which is an equivalent uniform annual cost of UEAC. And this then helps you understand and compare something with different lifespans. And so we're going to do that here. I'm only going to do one for the equivalent uniform cost of machine X or Y. I'll do X here. So the equivalent uniform cost for X, so this is for machine X, is going to be UACX. So that's $6,000. That's my initial cost. Notice costs are positive here because this is a cost analysis. So costs are actually positive. So it's 6,000. Now I want to spread that 6,000 across the length of the life of the machine. So that's A given P at 8% for 7 years plus the 150. That is already an annual cost. And that gives me an annual cost of $1,302. Let's do Y as well. The UACY is 12,000 initial cost. It's a little bit more expensive. Now I know A given P at 8%. In this case though, this machine has a 13-year lifespan and it has annual costs of $175. But the second machine, Y, also has a salvage value of $4,000 rather. And so that becomes negative. Remember, this is a cost analysis, so income is actually negative, cost is positive. And that is going to be $4,000, but that is a future cost. So I want to convert that to an annual benefit given a future cost of $4,000 over 8%, at 8% over 13 years. You crunch the numbers on that and you have $1,507, so that's D on that one. Which of these machines should you buy? Well, my annual cost for machine X is $1,300. My annual cost for machine Y is $1,500. So I would choose machine X because it has a lower cost. That would be option A. So my annual cost to operate machine X is going to be $1,300 per year, whereas my annual cost to operate machine Y is $1,500 per year. Again, if you're trying to compare things that have a different lifespan, you would want to use something like an annual cost analysis to do that. Okay. All right, rate of return is probably the most complicated of all these analyses, maybe the most useful one as well. So when we are doing all of these problems, I'm giving you a rate of return. It's like 8%, it's 6%, it's 20% or something like that. If only life was so easy that you could do that. It turns out that the rate of return varies. It varies in the past few weeks, up and down. So the amount of money that you can get in an equivalent investment in like the bank or buying bonds or something like that, you don't know. You typically don't know from year to year. Currently, we don't really know even from month to month. Usually it's a lot more stable than it has been recently. And so what a rate of return analysis will do is it will give you a percentage rate that is essentially kind of like a break-even percentage, and then you can make an estimated guess as to what you think the rate of return is going to be over the next few years and make your choice based on that. So instead of giving that percentage, what you're doing is you're actually calculating that percentage, and that sometimes helps you understand what your predicted rate of return is likely going to be over the next few years, and then you can use it to make that decision. The way you do this is you just set the present worth to 0. So the variable that you're looking for is that percent value, right? You know all the other things, but you're actually solving for that percent. And you lots of times can do that iteratively, or you can solve it. So some of these equations are going to be, this is the chart, these are all the equations. And so normally I give you the I, and you're going to just punch out what this number is. But if I is an unknown, then the math is challenging. You can certainly do that. Well, lots of times you'll just plug in different I values and just sort of iterate down until you get pretty close to where you want it to be. So you can solve for it if you have a math solver, or you just use Excel and you just plug in different values until you get to that present value equaling 0. Let's do an example. Example number 4. Company purchases a piece of construction equipment for rental purposes. Expected income is $3,100 annually. Useful life is 15 years, et cetera, et cetera. So for a rate of return analysis, I'm setting the present value of this equal to 0. I want to know what is the percentage rate that I could get that would set my present value equal to 0. So I'm setting my present value equal to 0. And so the purchase price is $2,500. So there's a minus 25,000. That is present value. I then have my annual income is 3,100. So that is income, that's a positive value. I'm gonna write it down below here. So that's 3,100. And I wanna know P given A at an I percentage rate for 15 years. Now that P given A is what's in these columns here. This is P given A for 1.5, P given A for 2.0. But the equation for P given A is right down here. This is the present value given a uniform series, is this equation right here. So you can see I appears 3 times in that equation. It would be ugly to solve for I. What else do we got going on here? So expenses are 355, so that is going to be a negative, that's a positive, this is a negative. 355, and that's going to be a present given an annual I percent for 15 years. And eventually this comes down to, these are the same factor here, you can see there's both annual costs. So it's 2,500,000, keep saying 100, is minus 2, actually that's a positive because I brought it on the other side, 2,745 times P given A at I percent for 15 years. Yeah, why did you do that? Okay.
Class is over.
Yay.
All right, come on. Maybe. There we go. Okay. So you can calculate what that factor is, right, based on those two. But if you just plug in, so P given A at 6% is, for 15 years, is a 9.72. P given A, these are just off the charts that I gave you, for 8% for 15 years is an 8.56. And so you can use those and do some approximation. That 6.95% is what you would get. So either you just use a math solver to solve for I in this case, or you just start to put in different I's until you kind of converge down to a value. So, and any of those methods would be fine. Okay, so that's trial and error. And so 6.9%, you would say if my interest rate is higher than, if the interest rate I think I can get is higher than that, then that probably makes this not a viable option, right? If I can get more money by just sticking the money in the bank, then it's probably not worth this investment. But if my rate of return that I can get by sticking it in the bank is only 3%, then this maybe is a good investment. So that's how you would compare that. So, okay. Another is break-even analysis is normally used to determine when the cost exactly equals the revenue. We talk about this lots of times, so break-even analysis. I think we talked about this with like solar panels and people who are doing the wind generation. So there's some initial cost associated with purchasing this thing that's going to generate electricity. Lots of times we'll talk about a break-even point. How long do I have to operate this solar panel or this wind turbine so that I can essentially make back the amount of money that I invested in installing this in my house? That would be an example of a break-even analysis. And so it's used to determine the required quantity or the length of time, sort of a payback period. So in this case here, the company produces a gear that's commonly used by several lawnmower manufacturing companies. The base cost of the operation is $750,000 per year. Cost of manufacture is $135,000. Gears are sold for $735,000 each year. How much must be sold each year to break even? So my cost is going to be $750,000 plus 1.35 times the number of gears. Oops. That's my cost. And then my revenue is equal to $7.35 times that number of years. And so I'm simply just going to set those equal to each other. So $750,000 plus 135, I'm just going to use N for number. When is that equal to 7.35 N? And that turns out to be a value of 125,000 years per year. So that is my break-even point. So I would need to produce 125,000 and sell 125,000 gears per year to break even. So if I can manufacture and sell more of those, I'm going to profit. If I don't manufacture or sell that many, then I'm going to lose money in it. So that would be an example of a break-even analysis. And the last one is a benefit cost analysis. This is a comparison between the present worth of all benefits divided by the present worth of all costs, and a project is desirable if this ratio is greater than 1. So I got little snow clouds here, snowplow A and snowplow B. And so I'm going to run the cost benefit analysis for A. So my cost, so my cost for snowplow A, and this is present, this is all present value. So that's 300,000 K, that's my initial cost, plus my operation and maintenance is 45,000, so that's 45. But I need to convert that to present, so that's present over annual at 10% for 10 years. That comes to $576,507. My benefits from the snowplow, so my annual benefits are 150,000, okay? And that I need to convert to present, P given A 10%, 10 years, that's $921,690. And so my benefit to cost ratio is that 921,690 over 576,507, and that gives me a benefit to cost ratio of 1.6. A benefit to cost ratio over 1 is obviously what we're looking for, so any benefit to cost ratio below 1 means it's costing more than I'm benefiting, and you should not do that. I'm not going to run the numbers. Essentially the same thing on B. You get a benefit to cost ratio of 2.01 if you want to just check out what B is. And so snowplow B would be better. I'm just getting more benefit for the amount of money that I'm putting into that product. And so snowplow B is going to be the better option. So that is a benefit to cost analysis. Okay, so I've covered all the topics for economics that you are going to see on the Fundamentals of Engineering exam. There is a homework assignment. It is due next Friday. It's 8 problems, something like that. So I encourage you to work through that, submit it. Some of you probably have done it already. If you have any questions, I'd be happy to answer any questions that you have about that. All right, that's all I got for today. If you have any questions about your attachments, please
Already had to take
see
macro.
Dr. Michael. If you have any questions about the writing, please see me. I will see you all on Monday, and we'll be talking about